In this video, I'll demonstrate how to interpret a speed-time graph. So we've got our speed-time graph in the top right-hand corner here. We can see that we have got an increase in speed for a period of time, 4 seconds, and then our speed plateaus. It stays constant. So the first question that we're asked is to describe the motion of the object. So the motion of the object, for the first 4 seconds, we have got an increase in velocity, or we could also say that the object is accelerating. So the object is accelerating for the first 4 seconds. And then then velocity becomes constant, or speed. Then speed becomes constant. In part B, we are asked to calculate acceleration for the first leg of the journey. Acceleration is equal to a change in velocity over time, and we're being asked for this first leg of the journey, so this triangle area here in the light blue. So time is going to be equal to 4 seconds. Our initial velocity is going to be, I should circle that one, our initial velocity is going to be 0. And our final velocity is going to be equal to 8. I should say speed, not velocity. So acceleration is going to be equal to 8 over 4, or 2 meters per second squared. And I'll put a box around it. Acceleration is equal to 2 meters per second squared. Next, we're asked to calculate the distance travelled in the first leg of the journey. We can actually do this using the graph. We can calculate the area of this triangle, and that will give us the distance travelled. So the formula for calculating the area of a triangle, it is half base times height. And we want to use the units that are given to us on each of the axes to work out what the size of the base is and what the height of the triangle is. So our base is equal to 4, and our height is equal to 8. So the area of the triangle is equal to half times 4 times 8. Which is equal to 16 meters. So in that first leg of the journey, the object travels 16 meters. And using the same logic, we can solve for part D as well. Calculate the total distance travelled. So we already know that in the first leg of the journey, the object has travelled 16 meters, and we did that by calculating, the area of the triangle. So now, to finish off and calculate the total distance, we just calculate the area of this rectangle and we add it to the area of the triangle. So the area of a rectangle is going to be the length times the width. So here we're going from 4 to 10, so the length is going to be 6 units. The width is going to be 8 as well, because we know that after it reached a speed of 8, it stayed constant. So its width is equal to 8, which means the area of our rectangle is going to be 6 eighths are 48 meters, and we want to add that to the 16 meters. Which gives us 48 plus 16, is 64 meters. Is the distance that the object travelled.